Alright, so this video is over scientific notation, which is a way to write really large or really small numbers. And then standard notation is just going to be the normal way you write numbers. So scientific notation is going to have a base number, and that base number has to be greater than 1 or less than 10. And it's also going to have an exponent. And the exponent, right up here, tells you how many times to move your decimal. This would be something that I would write into my notes. There's also, when you're in standard notation, if it is a big number, like 5 million or 3,000, that's going to have a positive exponent. If it is a small number, like any decimal number, 0.000005, it's going to have a negative exponent. 0.0004 is going to have a negative exponent. Now, scientific notation is pretty easy as you practice. So we're going to do 8 practice problems, and then hopefully by the time you come to class on Monday, you'll be ready to work them out, and you will catch on. So here we go. Let's start. I do apologize if the computer is running slow. So our first 4 sets of problems, we're going to have standard notation, and we're going to take it into scientific notation. So we have our base times 10 to our exponent. So what we want to do is we need to move our decimal to make a number between 1 and 10. Greater than 1, less than 10. So this is 5,400,000. My decimal would be right here at the end. And I would want to move it to make a number that's between 1 and 10. So I really want to move my decimal right here. And when I do that, that means my base number would be 5 and 4 tenths. And that number is greater than 1, less than 10. To see how many times I moved it, I go 1, 2, 3, 4, 5, 6. So 6 would be my exponent because I moved my decimal 6 times. And it would be positive because it's a large number. 5,400,000 is a large number. So my answer would be 5 and 4 tenths times 10 to the 6th power. That's how you write it in scientific notation. Okay, so let's try the second one here. 7,342. Some number times 10 to the exponent. Multiplying by 10 allows us to move the decimal every time. So 7,342, my decimal is at the end behind the 2. And I want to move it to make a number that is greater than 1, less than 10. So I need to put my decimal right here. 7.342. 7 and 342 thousandths. This is a large number, so I know my exponent is positive. And now I need to know what my exponent is going to be, so I need to know how many times I'm going to move my decimal. 1, 2, 3. So my exponent would be a 3. So it's going to be 7 and 342 thousandths times 10 to the 3rd power. And that'd be my answer. Now the next 2 examples are going to be a very small decimal number, meaning their exponents are going to be negative. That just means we're dividing by 10, so multiplying by 10. So same thing, number between 1 and 10 times 10 to a power. So I can already see my decimal right here. So now I need to move it to make a number between 1 and 10. I'm going to make it right here, 4 and 7 tenths. Then I need to decide how many times did I have to move my decimal to get there. 1, 2, 3, 4. Negative 4 times. Or 4 times, not negative 4 times. I moved it 4 times to make it a smaller number. 4 and 7 tenths times 10 to negative 4. So that, when I see this number right here, I know whatever standard notation number goes with it, it's a very small decimal number because of that negative exponent. So right here, times 10 to some number. I know right here it's a long decimal. I already know it's going to be a negative exponent. I need to make it between 1 and 10. So it's going to be 8 and 19 hundredths. Then I need to decide how many times am I going to move my decimal. 1, 2, 3, 4, 5, 6. It's going to be a negative 6 because it's a small decimal number. So 8 and 19 hundredths times 10 to negative 6 power would be my answer. So now we're going to go from scientific notation to standard notation. So the first one is 7 and 2 tenths times 10 to the 5th power. So start with your base then you're going to move your decimal 5 times because that's your exponent. But it's a positive exponent, so we're going to move it 5 times to make it bigger, which happens to make our decimal go to the right. 1, 2, 3, 4, 5. And then you fill your holes with zeros. And of course, you're going to rewrite it to make it nice and pretty. It's going to be 720,000. The next one, start with the base. You're going to move your decimal 3 times, and it's a positive 3. You're going to move your decimal 3 times to make it bigger, which will happen to go to the right. 1, 2, 3. Rewrite it. Now my decimal stopped between the 3 and the 2. So it's 6,543 and 2 tenths. That would be my answer. For now the negatives, same thing. Start with your base, 8 8/88, and you're going to move your decimal 8 times, but it's a negative, so you're going to move it 8 times to make it smaller. So making my number smaller, I'm going to move my decimal to the left. So 1, 2, 3, 4, 5, 6, 7, 8. It's a lot of zeros. Then I would rewrite my number. 1, 2, 3, 4, 5, 6, 7. And that is the number. Very small decimal number. Same thing here, start with the base. You're going to move 5 times, but it's a negative exponent, so it's 5 times to make your number smaller. 1, 2, 3, 4, 5. Filling your gaps with zeros. There you go, and that's your number. Also a tip is, like, when you have multiple choice questions, a lot of times the number they put in front is not between 1 and 10, so you can automatically cross those out, and we'll talk about that more in class. And then sometimes they'll put the same answer but with a positive exponent and a negative exponent, but we'll talk more about that in class.